the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, co-sponsored by Geocentric Consultants, H2M Architect Engineers, Brown & Caldwell, and BEM Systems.
Thank you for that great introduction, Dibs. Yes, like he said, we're always looking for great talent. That's one of the reasons why I love doing this and reaching out to young talented people like you. I sit in the New York office, but I think one of the great things about Brown & Caldwell is we strive to be one of the most virtual companies. So we have a framework, a culture, everything that is in place for us to just work remotely. I mean, I would say half of our staff are out at meetings or working from home or in different places, and we have great infrastructure and culture to be able to communicate and work virtually, and that gives me the opportunity to give you some experiences from projects that are out on the West Coast and all over the country. And so that's what I do, as I serve as one of our technical leaders for the company and bring expertise. And what that helps our clients with is giving perspective on, hey, what's New York doing? Or hey, what's LA doing? And so I think Brown & Caldwell really supports that working virtually, and so I think it's one of the benefits. We're about a 1,500, 1,600.
We're over 1,600.
Over 1,600 person consulting firm, and one of the great things about Brown & Caldwell is we are independent, and we do not, we're employee owned, so we get to make our own decisions, and I think that's really important when you start thinking about how the bottom line impacts companies, especially in a negative way, when you're really just thinking about cost all the time and reporting metrics. So it gives us the opportunity to bring really high-level thinking to our projects, and it's a fun place to work. I got to admit, it's a great culture, and I hope you think about that when you're looking at consulting firms and environmental engineering, if that's the route you go down. So today, I want to share with you some of my experiences. I know it's top of mind for a lot of this area and this region. Just by a show of hands, how many were here in 2012 for Sandy? So we got a few people that went through this. They experienced, they saw firsthand the rising waters. And I think what I want to bring to attention as we go through this is, green infrastructure, green stormwater infrastructure, whatever you want to call it, is mostly what I'm talking about is natural systems for what has traditionally been water quality treatment, but we're moving into a lot of more thought for volume retention and flood control. So that's what I'm going to focus on today, and just give you a little kind of a 101 on how we implement green infrastructure and what's been driving it over the past 15 years. It's really been kind of the momentum shift of going green for a lot of our municipalities, and then give some case studies of how we can use that when we think about resiliency, when we think about flood control. And so, I'm not going to go into a lot of sea level rise abatement, any of the shoreline structural improvements that we need to do, because that's not really what we're talking about here. What we're talking about is relieving the system. And if you like Sandy, I think a lot of the impact would have been a lot less if we would have had more capacity, relief on the capacity, because it's not only this storm surge, but it's also the amount of rain that's coming and the way the system can handle it. So without that, without anything else, I'm going to go in to this sort of overview of green infrastructure. You know, really it's natural systems, but it also could be other types of infiltration practices. And it's really about taking stormwater and runoff and infiltrating it before it gets into our sewers. Most of our sewers are designed to convey a certain larger flow off of our impervious areas for safety, right? We want to get everything off the street into pipes, and that's really what we're designing our infrastructure for. But if we can relieve that load during storm events by using what I call source control or green infrastructure practices, it can really help relieve that system. And that's where we want to fit into the picture of flood control. So typical practices, this is just showing mostly in the right-of-way. This can also be on site or private property or like schools, parks. Really it's rain gardens, different types of bioswales. You could be within the sidewalk. We call it curb extension is shown there in number 2. But also non-vegetated controls like trench drains and permeable pavements. So this is really kind of the main tools in the toolkit for green infrastructure. And really, because most of the impervious areas and most of the flooding problems that we have are in highly urban areas, we're usually talking about retrofits. So why all this shift to green infrastructure? Well, I mean, you probably heard of the triple bottom line approach. It's really about getting the added benefits. And if we think about large storage volumes or retention, gray, the antithesis, which is gray infrastructure, you're not getting all these added benefits. We're not getting improved habitat or carbon sequestration. We're not getting community health benefits. So this is really the reason we're pushing green infrastructure, and so many communities have been including it in not only water quality improvement projects, but also water quantity improvement. So in urban areas like this area, New York City, we have combined sewers, and really what that is when it rains, we don't have a separate storm system. Our sanitary and our storm are in one combined pipe. And so what happens is the runoff during rain events combines with the sewage from our waste stream, which is toilets, showers, sinks, everything you can put down the drain gets combined. And we've designed the system to overflow into the water bodies. And we do that because the alternative is when it gets at capacity, it would back up into foundation basements. And that's a much more worse public health effect. So we design them to overflow at regulators, and we set weir heights to overflow rather than surcharge back into the pipes. And this happens along lengths of the Hudson River, East River, all over New York City. New York City probably has about 500 combined sewer overflows and over 1 billion gallons annually. So it's a big problem. And green infrastructure is just one of the tools that is used to combat this water quality improvement. And that's really what's been driving the initial push for cities to do green infrastructure is combined sewer overflow abatement. This is the main policy driver that's been happening to drive most of this work. So I mentioned quality and quantity. I just want to share some of the quantity drivers. I mentioned the CSO policy. A lot of cities are under order. They have to do a certain amount of volume reduction by a certain time. So they do what they call long-term control plans to come up with big plans to abate a certain amount of volume. I mentioned that 1 billion gallons annually. Well, it's a multitude of projects that requires a lot of planning and modeling and assessment to come to a plan that you agree with your state agency, and ultimately the EPA is driving this. But what we're also seeing is flood control, where we have problems with low-lying areas or other goals where we're trying to meet, is also driving green infrastructure. And finally, another aspect is water reuse and groundwater recharge. In Southern California, they're looking at supplementing drinking water sources with stormwater. And so they're looking to recharge their aquifers with filtered, which through a natural system gets some treatment and into their aquifer to recharge their system. So that's another driver. And water quality, this is more where I'm trying to separate it, is the stormwater aspect. So this is in our separated areas where we don't have combined sewers, but we have direct drainage into these pipes. And these are other regulations through the Clean Water Act. You may have heard the terms NPDES, MS4. This is a whole other discussion, but these are water quality requirements, and they're specific constituents whether it be nutrients or solids, or even, we have Superfund sites like the Gowanus Canal. That's actually a Superfund site in itself. So there are other water quality drivers that drive projects that will include green infrastructure and other plans to improve the water quality of the receiving water body. And then finally, a lot of the mayor's goals in New York City, as an example, they're trying to do carbon neutral by, I don't know, what was it, 2050? Is that what we're trying to do? But I think that those are examples of those types of energy-related projects could drive green infrastructure. And we're seeing, for example, the local law 94, which is requiring all new buildings now to have green roofs or solar photovoltaic. So that's not even stormwater. That's really all driven by energy efficiency requirements. So that could include, which would have some stormwater improvements. So lots of different drivers. I want to take you through kind of a process of how we get from the beginning to the end of green infrastructure project. So there's three kind of different areas, and they're really about not only ownership type, but property type, right-of-way, public property, and private property. We usually think of them in three different pockets because the municipalities that are driving these projects are responsible for water quality or quantity, but they only have ownership of the public right-of-way, right? Or maybe public sites. So that makes kind of a low-hanging fruit in terms of implementation. Private property, we just can't say, we can create policies to drive green infrastructure, but we can also create incentives. There are grant programs that are also available, like New York City's Green Infrastructure Grant Program, which this project is in the Navy Yard, and it's a it's a urban rooftop farm that was funded through DEP's Green Infrastructure Grant Program. So you start with kind of a priority planning analysis. This is really using GIS and finding different layers to come up with where you want to hone in on your projects. But usually within, especially a combined sewer area, we look at what is draining to that combined sewer and how can we reduce the volume of runoff to that location. And so you use multiple layers. We use land use, we use impervious area, we use geotechnical data if we have it. We want good infiltrating soils, and we layer all these things up and come up with rankings, and usually have tools for this, whether it's a spreadsheet tool or some other widget that kind of varies between this municipality, but it helps us hone in on what are those priority projects. And that's kind of we go from 30,000 feet to 10,000 feet, look at where we can come up with these priority projects. And we also look at how do we, there are other kind of softer metrics that we look at. Maybe there's a neighborhood improvement district here or there's a goal to work with this community, and kind of layer in those other things, because other than, sometimes our other infrastructure underground, we don't really think about those impacts, but now we have an opportunity we're working above ground, and we have the opportunity to really bring in those other benefits and working with the community. So really all of our sizing of these facilities, they're taking runoff, they're infiltrating it, they need to be sized correctly. It really is all driven around the drainage area. So what is that delineation of the drainage area? In urban environments, we have these grid systems. It's pretty simple. You can actually have programs within GIS and AutoCAD that kind of do the main population, and you can check it, but it's very geometric, as you can see. Some cities it's going to be a lot different, but essentially you want to find out if a drop of water lands within this geometric shape, what direction is it going, and where will it end up in the pipe? So if this 432 drainage area, if we put a practice here, its drainage area is only going to be this big. We really want to get it close to the catch basin. You want to capture that water before it gets into the catch basin. So that is really important, and that really what drives the placement of your practice if you're doing it within the right-of-way or anywhere else, is thinking about the drainage area and where that practice is taking that water from, because we want to maximize the amount of drainage area and runoff that we can get. And then we have constraints. We're retrofitting in the right-of-way. We're thinking in the context of urban environments. We have a lot of clearances to think about. We call them offsets, setbacks, clearances, whatever you want to call them. It's about making sure we're a safe distance away from a driveway. Do we have enough sidewalk clearance that we're leaving for ADA requirements, and all those different kind of urban design aspects we need to think about, especially ahead of time if we're rolling out a program, and what those impacts are. So infiltration requires good soils. We really want to know what's happening underground. Each one of these practices has usually a permeability test as well as a soil boring done for each location. So that's a consideration that needs to be made in terms of getting that information. What we're trying to do is relieve it from the system. These systems can be designed with under drains if the soils are poor. You'll get some peak shaving on your hydrograph of the peak flow, but you're not going to infiltrate 100% of the flow. So what we really want are good soils, but if we don't have them, we can modify our design to allow for a practice to still provide that peak flow shaving. Before I get in too much further, I just want to, whoever wants to ask a question, we don't have to go back. We can stop, and please make this an open forum. If anyone has a question, please raise your hand and we'll stop and discuss it. So one of the things I talked about, some of the tools, if you're really going to get a big impact or a large city, you're going to have multiple practices. So Hoboken, I don't know how many they have, but New York City has probably 5,000 rain gardens in the ground right now. These are going to be highly distributed. They're not going to be this large end of pipe gray infrastructure control. So to get that impact, you're going to have to do these in many different places. And you want some consistency of design. And I think it's a lot of cities that come up with standard details. And so that allows that consistency to happen. It allows them to do projects quickly. Otherwise, imagine, 100 design contracts trying to review in a small department that many. If you have standard details, it's really going to help keep your program going, minimize the work, and making sure you have the consistency across all projects. And so this larger area represents a drainage area, and you can see all these green dots. Looks like measles. They are the rain gardens. And so when we kind of get these sited, we think about how we can package them. We don't want to have, a contract for 1,000, but just given the way a lot of cities have been approaching it, it'll either be several blocks, or it'll be a number of practices. And New York City kind of fell on a number of around 200. Probably I've seen 500 even, but that seems to be a sweet spot for them. That's around the $3 to $5 million construction range for them. So you're going to hire a contractor. They're going to be responsible for about that many, and that's how the designer would package them in a design package. Question?
So I see a bunch of like dots, I guess, sort of concentrated in one place. Is there a reason for that? Is it just because they're?
Yeah, I mean, I think there's a lot of reasons, but going back to the setbacks and the constraints, this might, I don't know what the deal is here, but maybe there's good soils here. Maybe these streets, all the sidewalks are too narrow, and we couldn't site anything or it had a bunch of mature trees. That also is, you don't want to remove trees to do a rain garden, but those are some of the reasons why you might have some groupings.
Sorry, and then I see so in package 3, I see multiple dots, I guess, all next to each other. Does that mean that there's more than one rain garden, or is it just one?
That's correct. Okay. That's correct. So, in a city, a catch basin serves usually a block and about half of the side of the street. So a street is crowned, and runoff goes to the curb, the other curb, and then it runs down the street. And sometimes you have multiple catch basins, but usually the way most cities are designed, there's 4 catch basins at an intersection, and they all drain half of the block. And sometimes the block, goes one way and the other way. But once you figure that out, you can kind of think of the number. But in general, one rain garden is not going to handle the entire block. So you have to have multiple in series. And you don't want these things too long. That's why because we want to give people access. We don't want to have them, walking and not being able to get off the sidewalk. So that's the reason why we have a maximum length. But that's a good observation. But you can see how many distributed rain gardens you need just within a neighborhood. Another question?
Yeah, so all these rain gardens are exactly the same almost, or are they all different in slight way?
There's some variations. I mean, New York City, for example, wanted a lot of consistency. They worked on that standard detail. Go Ducks. They worked on that standard detail for 2 years. And the reason it took them that long is it's not just DEP who's responsible for the stormwater or the CSO plan. It's Parks Department who is responsible for vegetation. It's DOT who owns the right of way. Everyone has a stake in the game, and it took a long time for everyone to come to the table and say, okay, this is what it should look like. So, and I think a lot of municipalities have found if you don't have any standard details, you're going to leave it up to the designer, and then you're just going to have apples over here and oranges over here, and it's going to be hard to maintain. And while I think this limits some of that creativity that might be available and out there, it really helps if you're trying to do this on a large scale. So I think they've spent probably about 800 million on these 5,000 rain gardens. So I mean, there's a big investment of public dollars, and they want to make sure they're performing right.
Right. What is the objective on? I'm sorry. Is there a question?
Yeah, I just wanted to know, for older sections of the city where you may encounter underground storage tanks or old utility lines, is there sort of that contingency placed into the project when you are scoping it out in the city?
Yeah, I mean, as much as that information you can bring up front as a constraint, we actually do a constraints analysis, and those are the types of layers or data that we try to collect and plot in GIS to stay away from.
Okay, so
and we also
like a red highlighted area,
like a hot spot, exactly. I mean, any underground storage tanks, even like gas stations, if they're in a drainage area, or auto body shop, concrete plant, right? A lot of stockpiling of sediment. You're going to have a bunch of runoff that is just going to clog your facility. So we try to stay away from those sites, and we identify them early on.
When you're taking on a project of this magnitude, is there a numerical objective of some sort that how much of the stormwater you want to be getting infiltrating as opposed to running off and getting out of the CSO? I know it varies probably from project to project, but what are you typically looking at?
Yeah, These are designed to manage the 1 inch of runoff, and that represents about 90% of our storms. So it's not really a flood control design limit, but more a water quality limit, and kind of what the normal approach to doing vegetative controls is you don't want to overload them too much, right? They're kind of set at a, what we call water quality volume design. So I think just to answer your question, the main goal for CSO areas is volume reduction. How do we get the volume out? Because that won't cause overflows. If you're in a separated area, your goal might be a little bit different. You might want to actually filter that water, and if you are going to release it back into the system, you want it treated rather than just removed. So for New York City, their initial goal was to manage 10% of the impervious area with of a 1 inch storm. So it sounds low, but it's actually a lot of water. 10% of the impervious area of the city is bigger than Central Park. It's about, if Central Park was a parking lot and it rained an inch, you'd have to manage that runoff. That's kind of the scale we're talking about here, like the entire footprint of Central Park.
Do they do, in the designing of it and planning of it, do they do an analysis that says how frequently they imagine the system will, or a model, how frequently the system will be exceeded, the capacity of the system will be exceeded?
Yes, yeah, I mean that's all part of the long-term control planning is to, you know, this is our baseline condition. They use hydraulic models to really replicate what's happening out there, and they ground truth it, and that gives you the volume and frequency of overflow. Is that kind of what you're getting at? And then we run alternatives, put in rain gardens, and that's kind of how they came up with the 10%. Is they said, well, we think we can do this much here and this much there. That'll give us 10%, and then as part of the rest of the long-term control plan, there's tanks, tunnels. You know, we're building a tank in Gowanus. Flushing is going to have a tunnel, underground tunnel to store the volume. So all of these alternatives are run through the model, as well as green infrastructure.
So that's really where I was going. So if they figure, okay, we're willing to accept actual flooding once every 10 years, then they have a secondary system. Is that what you're talking about with the tanks?
The tanks are actually just a volume. We store the combined sewer before it overflows, and then when the storm passes, we pump it to the treatment plant. So that's what all the storage is about. It's just about taking that volume before it overflows to the river. So we're upstream of any regulator. So for example, the Gowanus, we are building a 4 million gallon storage tank underground. And all that's doing is taking that sewage that would normally overflow to the Gowanus, putting it in a tank. And then when the capacity of the system is down after the storm, we're able to pump it either back into the system or directly to the treatment plant.
So that's for the sewage part of the flooding. This is for the runoff.
This is for, neither is flood, this is all driven by combined sewer overflow abatement. This isn't particularly flooding. I just was trying to go through the green infrastructure practice of how it's implemented. Yeah, so New York City hasn't been using this for flooding per se yet. But I will go into some other topics. Maintenance is really important. It's kind of one of the big topics, and one of the reasons why I think a lot of municipalities are hesitant to pick up on a lot of these practices because they're highly distributed. They do take different types of maintenance. You know, a lot of it is just keeping things clean, vegetation, normal pruning and plant replacement. But just something to think about, because it's what New York City does is they built up their catch basin cleaning crews because they're already at these locations driving around. They're already assigned to a specific area, and they just train them to know how to take care of plants instead of just sucking out catch basins. And then asset management is really important. When you start getting more of these systems, you got to keep track of them like any other asset. So having a database of your 1,000 different assets and having information associated with that, usually geographically, spatially, some GIS program where you can access that geospatially. So now I'm going to move into the flooding aspect specifically and how this is used as a resilient design for climate adaptation. So whether you agree with this person or not, I think we can all agree that weather is changing. I mean, the storm events are getting more frequent. We're getting more frequent intense rainfall. And so really what's happening is it's causing more flooding, stormwater pollution, and soil erosion. You know, I mentioned the impervious area. This is really just showing how increasing natural ground cover is going to reduce that overflow or the runoff, which creates problems in our urban areas. In DC, this was back in around the time of Sandy, but this was actually before Sandy, but a very wet year. They that is not a fountain in the middle of the street. That's actually a manhole with combined sewage that flooded. And in DC, there's apartments in all those basements. So what happened was this happened back to back, like week after week. And it's not really the amount of rainfall, but you can see the intensity is really what got this particular system, where it's raining an inch in 15 minutes or 3 inches in 2 hours. It's a lot of rainfall, and it really just, the system just can't, the capacity of the pipes, the amount of inlets spaced around the streets are just not going to be able to handle it.
Can you go back to the previous slide? So I would assume that more evapotranspiration means more potential rainfall. So how do you handle that, I guess you would say, trade-off?
That might be a microclimate thing. I'm not sure how to answer that because I'm not an expert. I mean, I don't see much of a difference. But because weather systems are moving, I'm not sure that's going to impact that particular area. Is that what you mean? If you have more evapotranspiration, it's going to create more but maybe not within that area. I don't know.
I haven't asked this yet, and I won't ask it because it's not relevant to the presentation. But how is green infrastructure catered specifically to the climates that it is in? Because if you have increased evapotranspiration in Arizona, that's different than an increase in DC.
Yeah. I think, the evapotranspiration, at least in our models, is pretty small in terms of the amount of volume, especially during a storm event. To me, the other environmental improvements like carbon sequestration, the more ground cover you have, and it's really the amount of runoff, like that 55 to 10%. I think if you were to compare these volumes, even though this is 40% of it's not the total volume of water. This is going to be a very small amount, where this is going to be a large amount of water. So we really care about the runoff, I think, in terms of flood abatement and water quality control. I don't know a lot of studies that have been done on evapotranspiration of retrofitted green infrastructure versus existing imperviousness.
Is it always true that it's an increase in evapotranspiration, or sometimes there is a decrease in evapotranspiration?
Let's
yeah,
off on the
I'm not sure. Yeah.
He has to finish first,
Yeah.
and then we can get back to this.
Yeah, I'm not sure. It's a good question, and definitely food for thought. So I'll go into this DC practice. The lesson learned here is really just about modifying designs to get higher design storms, larger conveyance. So this particular plan and cross section is a bioretention facility, and so one of the things about this project is the solution was, the long-term solution was part of a larger tunnel system. And so the ultimate reduction in volume and really the fix was about 10 years away. But these residences, if you saw earlier, they swept up all the combined sewer in their basement. They probably had to buy new appliances, and then it happened a week later. It was a huge political issue for the city. So they needed a quicker fix, and they were able to do these large bioretention green infrastructure practices within the right-of-way and modify their designs to take these bigger storms. And really, it was about making a lot of the conveyance wider, making the storage a lot deeper. This is 15 feet. You can see these are pretty large facilities that can handle much more than what's traditionally looked at for water quality. So there are ways to modify the design. Another project in Boston, this is a stormwater detention project. I still think of it as green infrastructure because there are some natural systems that we're looking for. But Boston has a lot of low-lying areas. It's like New York, it's in Hoboken, it's near open water, the bays and the ocean. So they do have a lot of low-lying areas, and they also have a phosphorus issue within the James River that they need to address. So they're trying to look at water quality as well as water quantity. That's two of their goals for this particular project that we're doing. And so we used, I know you can't see a lot of this, but basically we were looking for areas within Boston that were park space where we could temporarily flood it when there are large events. And so this is kind of like a temporary detention, and use whether they're wetlands or structures. And really, we just came up with a site assessment process that worked with the community. I think the biggest takeaway is that this is a rendering. This is not actually a picture, but this is something like what we would be proposing. And it required a lot of input from the public, because if you're talking about flooding park space, you better have some really good ideas and some improvements about that park space so that people can see what it might be like, because it's not something people are used to, and it's also something that is seen as a negative, right? So that was the biggest challenge for us going forward, is a lot of these spaces we need to look at what those added benefits would be, whether it be walkways or access or educational components, just improving hardscaping. The other project I wanted to go over is in Atlanta's doing a lot of green infrastructure, and they're looking at some interesting detention because they have some pretty major flooding problems within their collection system. These are not just flash floods, they are low-lying areas that get flooded frequently. Many different reasons why. A lot of it is just capacity. So how do we use natural systems? Well, this is an actual project. This is an area called Fourth Ward. This is a detention basin that is a pond at normal operating levels, and when larger storm events come, they close the gates and it fills up much higher. So they excavated a large area, and this is in very close to downtown. And I can tell you this neighborhood was pretty, there wasn't a lot going on. There needed to be a lot of improvement. And now they've built all kinds of, it's drawn a lot of residences and brought the neighborhood back around the stormwater park. So really great project. It just shows that you can do kind of flooding of park spaces and have it as an amenity. Another project in Atlanta, Boon Boulevard, another kind of neighborhood improvement project where we looked at doing a complete street with bike lanes and reducing the number of lanes. And so this was really taking into account the traffic impacts and traffic improvements and doing green infrastructure along with these other traffic improvements, just kind of showing how we could piggyback on a project. And this helped with, again, some localized flooding in that area. The last thing in Atlanta is, this is in Roswell, which is outside of Atlanta. They're doing a number of permeable pavement projects. And I bring this up because it has a pretty large surface area if you're willing to do it curb to curb. And it can handle very high surface runoff. So it could be a real good solution for localized flooding. You also don't need to pipe these areas into get storage, because if you have a low-lying area, it'll already be infiltrating at the surface. So permeable pavements, and what they are, the product now is this interlocking paving design, and it really uses, each one of the pavers themselves is impervious, but it uses the gap between them to allow for the infiltration. And what that does is it creates a pretty robust, structurally robust configuration that can handle very heavy traffic loads. So these are all like H20 road designs.
Is it easy to like pick up or like tear apart if you need to get to like utilities?
Yeah, see, your seamless utility access. That's one of the benefits. So you can pull these up, do your work, and put them back in place like nothing was really seamless.
Do they clog at all, the spaces between the sediment and?
Yes, yeah, you want to keep the leaf litter. You want to make sure there isn't high sediment loads to the drainage area. You do need to vacuum these once a year at least and replace the sediment, but it's pretty simple. I mean, these are it's pretty small aggregate that you put between the pavers themselves. But basically below this is very similar to a normal asphalt system, but there's a storage layer of large stone that creates that volume that can store the storm volume.
5 minutes.
Sorry. Is there like an issue because there's obviously cars driving on here with like the oil and whatnot, like, 'cause that's also infiltrating. I feel like this is more of an issue like in the road than it would be on the sidewalk area. Does that get taken into account?
Yeah, it certainly would. I mean, I would say your stormwater runoff, if it were to go, if this were impervious and you had curb and gutter runoff going into a rain garden, it's going to have the same load. So the petroleum load would still go into an infiltrating practice. If you're directly discharging into a receiving water body, then you're just going to send it there. So I think there is some treatment with the filtration through the system, but there's some studies out there. I mean, look for them, but I think biofiltration is going to be the best, and that's why we look, usually when we're looking at water quality treatment, we think about bioretention, bioswales as the first line of defense because it gives the most amount of treatment. I'm going to breeze through these. This is in San Mateo County, cool project. This is still under design, but you can see we're using this beautiful creekway to do park improvements and allow for flooding. A lot of this is done through modeling and looking at your collection system model. We use SwimInfo Works. I don't know if you guys are familiar with these programs, but they're pretty powerful. They take a lot of time to build, but once you build them, you can run all kinds of scenarios through them, and that gives you the volume reduction you need. This project is a stream. They're having lots of flooding. This is in Garner Creek, which is also outside of Atlanta. They had flooding around the riverbanks where they were storing buses. So you can see there was some damage there. Pretty poor conditions. This is kind of hard to see, but there were green infrastructure elements within that stream bed that we sort of created to manage a lot of the runoff that was coming from a very highly impervious parking lot of the school. and we just worked with the school to have cheap labor. No, I'm kidding. We worked with them to get input on the design. So it was a really, you know, I would just say it's really important to make sure that when you're doing these projects to think about the community, because we're not just doing, you know, storage tank underground. There's a lot of real opportunity to get people involved, get them educated, and so that's just a message I want to take away from this. So I got another meme in here, sorry. But yeah, the takeaways here are just to, you know, green infrastructure can be designed to really provide that capacity relief. You know, we're not talking about, you know, stopping sea level rise. I mean, there's some carbon sequestration that we're going to have, but it's not going to change the global climate. But we can address localized flooding issues and really provide that capacity relief so that when we do get another Sandy, the impacts within the collection system where we live are going to be less, and it's really going to reduce the impact of flooding. So you can modify these designs. You know, most of them I talked about are about that 1-inch storm, but you can really bump up the design storm. So you know, traditionally we're at like a 1-year storm event. You can go up to 25, maybe even 50-year storm events if you upsize a lot of these facilities. And think about regional detention, that Boston project. You know, really, we just started with looking at low-lying areas. Where can we offline? You know, this is all gravity flow. We're not pumping stuff to natural systems. We're finding those low-lying areas we can divert flow into, provide that, and then talk to the community about how can we, hey, you know, this is a good idea. Here's the issues. What can we do to really make this project happen? So provide those additional benefits. Think about what those community benefits are that you can incorporate into your project to make it more palatable and to make it really an actual project that can happen. Thank you so much.